Hey there, science fans! Welcome back to another exciting episode where we delve into the wonders of science and technology. Today we're diving into the fascinating world of nuclear reactors and how they generate electricity. It's a topic that's both intriguing and incredibly important for our future. You know those giant dome-shaped buildings? Those house nuclear reactors, and they're like giant powerhouses producing massive amounts of energy from tiny atoms. It's amazing how something so small can create such a huge impact. We're going on a journey to uncover the secrets behind this incredible technology. From the science of nuclear fission to the engineering marvels that make it all possible, there's so much to explore. Get ready to learn how we can harness the power within atoms to keep our lights shining bright. Imagine a world where energy is abundant and clean. Now, before we get into the nitty-gritty, let's get one thing straight. Nuclear power is a safe and reliable source of energy when handled properly. Safety is always the top priority in nuclear facilities. It doesn't produce greenhouse gases, which is a major plus for our planet. Compared to fossil fuels, nuclear energy is a much cleaner option. So buckle up as we explore the science behind this amazing energy source. From the basics to the advanced concepts, we're going to cover it all. Stay tuned and let's get started. At the heart of every nuclear reactor is the fascinating process of nuclear fission, a powerful method of generating energy. Imagine this. We take a uranium atom, which is kind of like the essential fuel for our reactor, and prepare it for a remarkable transformation. Now, this uranium atom is special. It's a bit wobbly and unstable, making it perfect for our needs. If we hit it with a neutron, bam! It splits into two smaller atoms, a process that is both dramatic and incredibly powerful. This splitting releases a tremendous amount of energy, mostly in the form of heat, which we can then harness for various purposes. It's like splitting firewood, but on an atomic level. The energy released is far greater and much more efficient. But here's the really cool part. When the uranium atom splits, it also releases more neutrons, which are crucial for sustaining the reaction. These neutrons then go on to hit other uranium atoms, causing them to split and release even more energy and neutrons, perpetuating the cycle. It's a chain reaction, like a line of dominoes falling over, releasing energy with each tumble. This continuous process is what makes nuclear reactors so powerful and efficient in generating energy. Now, all that heat generated from fission needs to be harnessed somehow. This is a crucial step in the process of generating electricity from nuclear energy. That's where the reactor core comes in. It plays a vital role in converting nuclear energy into usable thermal energy. The reactor core is like a giant pressure cooker filled with fuel rods containing uranium. These fuel rods are meticulously arranged to ensure optimal efficiency and safety. The fission process happens inside these rods, generating an incredible amount of heat. This heat is the primary source of energy in a nuclear power plant. This heat is then absorbed by water flowing around the fuel rods. The water acts as a coolant, preventing the reactor from overheating. Think of it like this. The fission process is like a campfire, and the water is like a pot placed over the fire. The heat from the fission is transferred to the water, just like a campfire heats a pot. The heat from the fire, fission, heats up the pot, water, and that's how we start to generate power. This steam is then used to drive turbines, which in turn generate electricity. Section 4, Steam Power, turning heat into motion. Remember all that hot water we talked about? Well, it gets so hot that it turns into steam. This steam is then piped away from the reactor core and into a turbine. A turbine is like a giant fan with blades attached to a shaft. When the high-pressure steam hits these blades, it causes the turbine to spin really fast. The faster the turbine spins, the more power it generates. It's all about converting that heat energy from fission into mechanical energy in the spinning turbine. Section 5. Generating electricity, the turbine's role. Here's where the magic happens. The spinning turbine is connected to a generator. A generator is basically a giant magnet surrounded by coils of wire. As the turbine spins the magnet, it creates a flow of electrons in the wires. And guess what? That flow of electrons is electricity. So, from splitting tiny atoms, we've now generated enough electricity to power homes, businesses, and even entire cities. Pretty amazing, right? Section 6. Cooling and recycling, completing the cycle. Now, after the steam has spun the turbine, it needs to be cooled down and turned back into water. This is done using cooling towers. those iconic structures you often see next to nuclear power plants. The steam is condensed back into water, which is then pumped back into the reactor to be heated again. This closed-loop system ensures that water is constantly reused, minimizing waste and environmental impact. So not only does nuclear power provide clean energy, but it also conserves water, making it a sustainable choice for the future.